Okay, welcome back. This is the part 3 of the lesson 8.8 in AP Calculus curriculum, volumes of cross sections, triangles, and semicircles. In this video, we're going to do semicircle cross sections with simple functions. I'm going to give you an example of one. Here again is what we've gone over, how we go about setting up these cross section problems. We need a description in the problem, the relationship between, oops, this is a semicircle. Forget about this. This is for the triangle. Okay, so we're going to look at a problem where we have f of x equals ln x. Semicircular cross sections are perpendicular to the x-axis. The base of the solid is defined by the region bound by f of x, the line x equals 10, and the x-axis. So we're going to start by sketching the curve, sketching the region. Remember, f of x equals ln x. It's one of those graphs. We need to know, let's say, here's line x equals 10. And so we're looking at this region. We'll draw one rectangle in there. And this time we're looking at semicircles. So the width of that one rectangle is dx. This is where x equals 1 because ln 1 is 0. And we're going to go from there. Okay, so I'm going to draw one cross section here. The width is dx. The length of this, because it's between the function and the x-axis, the length is just f of x. So this is going to be ln x. Now, this is a semicircular cross section. Recall that the area of a circle is equal to pi r squared, which means the area of a semicircle is going to equal pi r squared divided by 2. So the radius is what we need to find in order to create an expression for the volume of this one cross section. And the radius of the semicircle is going to be 1/2 the length of that rectangle. So here we're going to have the radius is going to be ln x all divided by 2, or 1/2 times ln x. As a matter of fact, I'm going to write that as 1/2 times ln x so I don't mess up and make anybody think that that divided by 2 is inside the ln x. I'm going to write that as 1/2 ln x. So if this is the case, then the volume of this cross section is the area of the face, which is the pi r squared over 2, times dx. So here, the pi over 2 times the radius squared. We could look at that as pi over 2 all times the radius squared. So the volume is going to be pi over 2 times the radius, 1/2 ln x squared, and then times the width of the rectangle, dx. That's the volume of one single cross section. We're looking for the volume of all of them. So we're going to get that by doing the integral from, whoops, this is 1 this time, to 10. Now we're going to integrate the volume expression, goes in here. So I'm going to put the pi over 2 on the outside because it's a constant. I'm leaving the 1/2 because it's inside that square. I could square, get 1/4, and then pull the 1/4 out, but if I just leave the radius in there. A lot of times on the FRQs, all you have to do is set up the integral, and then you don't have to evaluate it. But if you did have to evaluate this, this is one we would do in a calculator, on a calculator portion. So I'm going to go ahead and do that in a calculator. Recall that we do pi over 2 times, now we're going to do math 9 to get the integral. Then our limits of integration are 1 to 10. Inside the integral, because I'm squaring it, I'm going to open up a new set of parentheses, and I'm going to do 1/2 or 0.5, either one, times ln x. And then since all of that is squared, I have to close the parentheses on the ln x and the 0.5. So there's got to be a parentheses containing all of that expression in your calculator. and square that. All of that should be contained inside the parentheses for the integrand. Then put in our variable of integration, which is going to be x. So in the calculator, what I've typed in looks like this. In the calculator, I've got pi over 2, and then the integral from, 1, to 10 of, it automatically opens that parentheses. Then I'm going to put a new parentheses in there, 0.5 times ln x. It's got a parentheses around the x. I'm going to close another parentheses, so I get a 0.5 ln x all contained. Square that, then it closes another parentheses times dx. That's what's in the calculator. And it's a 10 there. So now I'm going to have the calculator calculate that. And it gives me 9.8. It could be 4 or 5. Remember, you can chop or round. So this is going to be units cubed because we're doing volume. And that's an example of a simple function with the semicircular cross section. The key is the geometry. Understand you're getting the area of the semicircle multiplied times dx. That gives you the volume of one cross section. Then integrate the cross sections from your lower to your upper limits of integration times the area function pi over 2 times r squared dx. That's how we do it.